Morning. Another day of Mrs. Miller being gone. Um, Mallory's all good. She's going to go back to school tomorrow, but I still have a fever. Hopefully I'll be better. Hopefully I'll be better by tonight. I'm going to get lots of rest. So I'm doing this lesson and then I'm going to bed. Okay, so tonight's homework is textbook, page 700, 9 through 31 odd. And we're going to take permutations and combinations to the next extreme. So, review. What are permutations and combinations? Well, it's talking about all the different outcomes, possibilities. Permutations are possibilities. Oh, that's really messy. Permutations are possibilities that have order, and combinations are possibilities that don't have any order. It's just randomly chosen. Okay, preview. What do permutations and combinations have to do with probability? Well, we can have possibilities, but once we find out how many different possibilities, the probability would be getting one of those possibilities out of everything. So this is kind of sometimes says this, like this. If I want to have something a success, then I need to add all the possibilities and take my successes and divide it by all the possibilities. Sounds very confusing. It's really not that bad. Okay, I will be able to use permutations and combinations to find probabilities. We're using the same thing we did yesterday, only we've got to divide it by all possible outcomes. Alright, so let's just dive in and do one. Put your pencils down and just pay attention. Alright, Roman has a collection of 26 books. 16 are fiction and 10 are non-fiction. So he randomly chooses 8 books to take with him on vacation. What is the probability that he chooses 4 fiction and 4 non-fiction? First of all, we can ask ourselves, does order matter here? He's just choosing books. He's not putting them on a bookshelf. He's just choosing. This would be a combination. So how many different choices or possibilities would be, let's see where they're asking us, 4 fiction and 4 nonfiction? So from what we did yesterday, if I were to be talking about fiction, I would say, well, there's 16 total fiction books. So 16 combination 4. And what's the other one? Nonfiction. And there's 10 nonfiction. So 10 combination 4. This is how we found out all the possible outcomes of choosing 4 fiction and 4 nonfiction. All the possibilities. We're going to divide that now by our total. So I have a total of 26 books. And I'm choosing 4 and 4, which is a total of 8. So just one extra step today. And you have to think about it a little bit, but just one extra step. So if I were to put this in my calculator, 16 combination 4 would be 1820. And 10 combination 4 would be 210. And I'm going to divide that by 156,000. Sorry, I had that wrong. It's in the million. 1,562,275. Can't erase and I don't have this plugged into the board. Okay. Which gives me about 0.24464. So the probability, all right, probability of getting 4 fiction and 4 nonfiction is about 24 point, see if the decimal moves 2 places to get percent. So the 6 would turn the 4 into a 5. So 24.5%. So not too bad. Just one extra step, and you've got to, put some thought into it. But I'm going to make sure I give you guys plenty of time in class today to get at least half your homework done, and I've cut the homework down as well. All right, let's try another one. For next semester, Alisa has signed up for English, pre-calculus, Spanish, geography, and chemistry classes. If classes are assigned, huge, right there, assigned. That's going to be permutation right there. All right, if classes are assigned randomly and each class is equally likely to be at any time of day, what is the probability that Alisa's first 2 classes are in the morning? First 2 classes in the morning will be pre-calculus and chemistry in either order. Okay, these are the ones that I find the most challenging. So hopefully you guys can follow along with me without me being there to take questions. Okay, so if you think about this, she's got 2 morning classes and 3 afternoon classes. That's what they're asking. So we've got to make sure that we've got all the possible scenarios for both. It says they all have an equal chance. So there's 5 different classes here. So I'm going to use permutation, first of all, because it's being assigned, because they're going to be in a certain order. We just have to find all the possible ways that it can be in order. All right, so we're going to have 2 classes in the morning, permutation 2, or 2 pick 2. Then we're going to have 3 classes in the afternoon and find all the possible ways we can have 3 different classes in the afternoon. And finally, we have to divide that by all the possible classes. So she's got 5 classes, and we've got to come up with 5, picking 5. All right. So hopefully that makes some sense to you. I know it's a little bit difficult. I hope you understand why it's a permutation, because it's assigned. We've got to account for all the possibilities in the morning, plus we've got to have all the possibilities in the afternoon, because they both factor in. Let's see. 2 permutation 2. If I were to put that in a calculator, I don't have it in front of me. I'm just going to do it in my head. So it would be, I'll do my work over here. 2 factorial over 2 minus 2, which is 0 factorial. That would be 2 factorial. This one would be the same thing. 3 factorial over, like 5 factorial, because 5 minus 5 would be 0 as well. That one I didn't even need a calculator for. So 2 factorial would just be 2 times 1, or just 2. And 3 factorial would be 3 times 2 times 1. We don't need the 1. And 5 factorial is 5 times 4 times 3 times 2 times 1. Might as well put approximation sign there. Cancel some of these. I've got 2, and a 2 is 4, and 3. That's 1/10. So there's a 10% chance. So go ahead and copy that one down. All right. Third one, suppose 2 dice are rolled. The table, these are actually nice and easy to do, so don't be scared about all these words. Okay. Suppose 2 dice are rolled. The table and the relative frequency histogram show the distribution of the sum of the numbers rolled. Use the graph to determine which outcomes are least likely. What are their probabilities? So it shows you if the sum of the dice would be snake eyes, right? 1 and 1 is 2, or 6 and 6 is 12. Those are the least likely. The most likely is 7. Because you've got lots of different combinations to come up with 7. You've got 2 and 5, 3 and 4, 4 and 3. So it's asking us for the least likely. So the least likely are 2 and 12. And their probabilities are 1 out of 36. That's it for that one. Pretty easy. Okay, use the table to find the probability of the sum of 11. What other sum has the same probability? Well, sum of 11 is here. And you notice the symmetry here? That's always going to work out like that. So the sums of 3 and 11 have a probability of 1 over 18. So you've got a few in your homework like that where you just have to look at the chart or look at the table and read it. Okay, so why don't you guys try one on your own? Ainsley has a collection of 15 CDs, 5 are jazz, and 10 are blues. She randomly chooses 7 CDs to take with her on vacation. What is the probability that she chooses 2 jazz and 5 blues? So you guys try this one, pause the tape, and then on the next page I'll have the answer and have it worked out for you. Okay, so you ready to see which one's correct? Here we go. C, 39.2%. This is how I worked it out. We had out of 5 jazz, we were choosing 2 of them. And out of 10 blues, we were choosing 5 of them. So 5 combination 2 and 10 combination 5 for a total of 15 CDs. We are choosing 7 if we were to choose all of them. Notice these 2 numbers add up to this one. These 2 numbers add up to this one. Okay. Last one. Suppose 2 dice are rolled. Table and the relative frequency histogram show the distribution of the sum of the numbers rolled. Use the graph to determine which outcomes are the second most likely. What are their probabilities? So go ahead and pause, give you guys a second to discuss it, and then I'll have the answer on the next page. Okay, so hopefully you guys are ready. So going to the next page would be B. It says, use the graph to determine which outcomes are the second most likely. Second most likely. This is the first most likely, so these 2 are the second most likely. So 6 and 8. All right, so why don't you get started on your homework, and I'm going to go ahead and post the answers on School Loop. Have a good day, guys. Hopefully see you tomorrow.